my background's in the field of geomatics, but the field of geomatics has gotten quite broad over the last few years with advancements in software technology, mapping, that kind of thing. So I guess the lines are getting a little bit blurred between surveying and mapping, with everything getting more accurate kind of in the end. So more things are kind of going towards the survey side. So my background's been at Stantec for the last 11 years, kind of started in the field and worked my way up to kind of the role I'm in now. Like I said, my background as an Alberta land surveyor, the legal land surveying side of things, but been involved in UAV applications and remote sensing and LiDAR, I guess, within our company. So I get to kind of look at new technology. Got to be able to do that for the last 2 years, which I enjoy. So everything kind of fits together. So I was at a conference back in February this year, and it's kind of a similar theme. It was an Autodesk conference on kind of a capture, compute, create theme, where it's basically data capture and data computation or data analysis of what you do with the data, and then there's kind of a visualization or create aspect to it. So I'm kind of following a similar theme here. I'm going to talk a little bit about the data capture side of things for all the different sources of data that are available, how you can analyze them in some of the tools that are available to you as planners, engineers, etc. And the visualization aspect of it is to how we get past the 2D aspect of maps and plans and maybe more into real-time 3D environments. So I'll be showing some of those concepts here at the end as well. So just to start off, I guess the big thing is all projects start with data. This is kind of one of the big things that's I run into all the time, I guess, with my background being as a land surveyor, and surveyors are quite anal about how accurate everything actually needs to be. So we kind of deal with more of the good data of being, it's very accurate, very spatially referenced data. There's also a lot of bad data that floats around. That can be different vendors, it can be different accuracies of data, different years of collection. And then there's a lot of questionable data that nobody has any idea where it came from. Found it out of an old CAD file or plan from years ago, traced it off of onion skin or something like that. There's various sources of things. So kind of that's the concept we need to realize up front, is that there are different sources, so understanding where they come from is very important. So one of the big ones, I'm assuming the majority of you have probably heard of LiDAR. Maybe you use it in kind of your daily work, but I know most people kind of use the end product of LiDAR, not necessarily a lot of the raw data, what else you can do with it. So I'm going to kind of go over a bit of that. So LiDAR, basically light detection and ranging. It's basically a laser range pulse, similar like a total station, like a survey instrument, that fires a laser pulse, returns it, and based off reflectance, and it can actually get measurements to it. The benefit of LiDAR, though, is that it does it hundreds of thousands of times a second. So there's different platforms you can capture data in. So the example you see here is from an aircraft, which is typically the majority of the data you capture for large-scale terrain information. So it's very fast, and it is based off of natural reflectance. One of the big things with aerial LiDAR, you see in the diagram on the right there's actually several echo pulses that get returned. So typically, there's up to, I think, about 4 returns for a lot of aerial LiDAR sensors, so it gets basically 4 distance observations from every pulse that gets sent out, which is how it can actually start to penetrate foliage. So it gets tops of trees, middle of trees, and eventually it gets to the bottom by the last pulse. So typically everybody kind of works with the last pulse data set, which is like a bare earth surface or a ground surface. But there's a lot of other data that's part of it that nobody really exploits and what you can do with, and a lot of tools you can kind of deal with that information. So again, kind of platforms, aerial being the most typical. I kind of threw a few accuracy specs in there just for an idea of the good data, bad data, and then just how to merge it all together. So aerial data is typically only get to about 10 to 50 centimeters, horizontally and vertically. Better vertically than it is horizontally, so definitely things to keep in mind when you're dealing with large-scale terrain data. It is very good, but part of that depends on who collects it, when it was collected, what sensor was used. Mobile scanning is kind of the next aspect of things that we're starting to see more and more every day, where it's actually, I don't know, I wish I had that vehicle for survey, but we don't have that thing. But, so it's actually on the top of the vehicle, actually has 2 rotating scan heads. It's got up to 6 to 8 cameras on it, as well as GPS, inertial system, other types of sensors that can be integrated into it. So technically this system can actually drive at highway speeds and capture near survey grade data. So this system, I don't have it, but there's a couple that are kind of floating around in Alberta. All of, again, various accuracies. This is kind of the Cadillac one. It's about $1.5 million for that scanning system. But like I said, the benefit of it is it can actually scan close to 1 million points a second while it's driving at 100 kilometers an hour down the road. So I've got kind of some sample data what that is afterwards. So it's becoming a lot more prevalent. Very large areas can be captured and can be used for a wide array of applications for terrain, site visualization. You can use it for utility information, etc. So next is kind of terrestrial. This is kind of what we more so specialize in at Stantec. We've got 14 terrestrial laser scanners kind of scattered throughout our various offices. So it works similar to a conventional survey equipment where you actually takes observations with it. Thing is, again, it can be up to 1 million points a second. So it does a full 360-degree scan and captures a kind of a realistic looking image, point clouds, just a lot of data. Next step, of course, it's kind of coming with technology, is this is actually being integrated into smartphones. So this is actually an attachment from a company out of the States. I've got one. It works okay. It's getting better. But Intel's got a new chip that's coming out to actually be able to start doing laser scanning directly from a cell phone. You know, with a grain of salt, you definitely have to worry about accuracies of those things. They are on a mobile device, so positioning of them are suspect. You know, you've seen the Google Maps on how close you are in some of the roads anyways, but that's kind of what it bases off of. But once technology advances with better GPS chips, better inertial systems, etc., more accurate, less expensive systems, we could have basically on every smartphone tablet, you'll actually be able to have a laser scanning device for whatever applications you see fit. But a lot of video game industries and indoor visualization, that kind of thing, is based off of smartphones. So, and again, at the bottom, various accuracies by technology as well as the vendor and system of who does the collection. So just buyer beware when something comes in as a cheap price, it's usually just that, but the data is a less expensive sensor. So, but again, once you kind of get a handle with some of the data, you might get a feel for that as you move along. So just kind of show you some of the different data sets. This is actually an airborne LiDAR data set. So you can kind of see the level of detail of the raw data. Typically, like I said, the data that most people will use is like a bare earth data set in the end, which is a really parsed down data set. They kind of filter it down to about a one or 2 meter point spacing. You get a point on the ground every meter or two, very gridded pattern to get a really nice terrain surface. But the benefit of LiDAR here as well is that you actually get all this other data for various levels on building tops of vegetation. You can make out power lines. And this is all, again, from an aerial platform that flies quite high above. They can capture quite large data sets. There's a lot of vendors in Alberta that actually capture LiDAR data. There's tons of data that exists off the shelf, and it's available kind of to order through a number of web interfaces. So, but that's the detail. You can kind of make out basic shapes of objects. So this is actually for the Blatchford project. You can kind of see the old airport tower that's there. These are all the surrounding buildings. So the nice thing about it, again, is that it can penetrate foliage. They try to capture data from airborne LiDAR in leaf-off conditions. They'll try to do it in like the spring, fall, so it can actually have a better chance of actually getting to the ground. So that's kind of a LiDAR data set. You get about 6 to 7 points per square meter in the raw data set, which is way more than what you typically would want, but it allows you to do a lot more with it. Then we kind of jump into one of the mobile LiDAR sets I was talking about. So this kind of looks like an image, but this is actually a project just kind of, well, I think it was in Calgary that we did. We hired a third party to actually capture a bunch of data set in the mall. So you can see that every point you actually see there is just that. Everyone is an actual point data set. Color imagery is overlaid over top, so every point now has a color. So it looks like an image, but you can see like there's the home sense and winners in the background. If you kind of zoom into the level of detail, this is kind of zoomed into a curve. This is the level of detail you can actually get from a mobile laser scan data set. So accuracy can be down to a couple centimeters. But again, this entire parking lot can be driven in about an hour, and you capture this incredibly robust data set with imagery and point cloud for as large of a site as you need. It's a lot of data. That's the downside of it, and that's one of the reasons why we haven't got into it yet, is some of these systems can capture about 1 terabyte a day just of raw data and imagery. So our IT group doesn't like our terrestrial scanners because it's already a lot of data, but let alone when you jump into something like this and you want to keep it busy because it does cost a lot of money. We haven't really been able to convince our IT guys that it's a really good investment to jump into yet. So, but it's the next logical step that we want to get into. Terrestrial scanning, kind of something similar. This is actually the dentistry building on campus here. So very accurate, a little bit more accurate than mobile laser scanning data, but it's all done from a static location. So there's a few different disadvantages to terrestrial is the fact that it can only get what it sees. So wherever you set up and what you measure is basically all the data that actually gets captured. But you can see kind of level of detail as you zoom in, say, on a building corner. You can actually make out every little, window, ledge, corner of building. So we use this a lot for our survey applications for doing existing conditions information. We'll actually scan features instead of surveying them manually, because you can actually capture all the data and extract what you need out of it in the end. There's a lot of really impressive tools to basically capture planar information. We've got software that can extract piping automatic. We can classify information to kind of layer or organize data. So it's quite, it's a lot of data, but it's very valuable for us as a surveyor, since we can actually use it for a lot of site surveys, a large scale capture. We need to get in and out. There's a lot of safety risks kind of inherent to a project. So kind of an interesting application that we use quite a bit now. The other nice thing, again, is it captures imagery to it. So this is kind of getting into it basically captures a 360-degree spherical image. So this actually isn't points. This is an actual image that gets extracted with it, but everything's measurable. So you can have some free online viewers that you can actually have measured distances between objects within this free viewer. You can pick off coordinates. You can do other data sets. There's even asset tagging information you can do with it. So if you actually have, like we do it a lot for like plant site facilities, where you want to actually scan a location, tag assets, you actually have a bit more of a, kind of more of a three-dimensional GIS application in a web browser. So that's kind of, we use it a lot now. We've been doing it for about 8 years, and technology has just advanced quite a bit on this front as well. That kind of leads me into the next aspect of things, being drones. I know there's a huge buzz about them. We got into it 2 years ago at our company. So you kind of hear a few different words floating around between UAV, UAS, RPAS, drone. Drone's kind of the biggest one out there. It's always had a negative connotation to it, being attached to military applications, that kind of thing. I don't really care. You call it what it is. Basically, it's a vehicle that doesn't have a person on board. So it can be of any size. So our little system is this. Basically a 3-pound foam plane with a camera. And we typically go with the UAS designation. So there's unmanned aerial vehicle, unmanned aerial system. So this on its own is a vehicle. This coupled with software is considered the system. So we typically kind of go more as UAS. RPAS, I don't know, they kind of dreamt up another acronym for remotely piloted aircraft system. It's all the same thing. They're magical flying machines is really what they are. Various levels of accuracies. They don't, I got into it as a hobby a couple years ago. I had a couple of my own as well. They're becoming a lot more prevalent everywhere. I'm sure you've all seen, probably drones might have been flying around your neighborhood. Maybe a neighbor's kid got them or a dad, I guess, probably got it for Christmas one year. So they do come in different sizes. You get a very basic one you can buy off the Apple Store that runs off your iPhone. So it's considered a drone. It's got a camera on it, very small, very lightweight. Then we can kind of jump into, this is one of the later ones. This is one of the big ones. It's, I don't know, DJI is one of the big consumer drone companies. They just recently valued, I think, at $10 billion last year for a drone company. I don't know, they're selling a lot of the things because they're about the $1,200 to $1,300 price mark now for a system like that that's got a high-end camera on it to actually do image capture video. Next step up is something like ours. Ours is about $25,000. Doesn't look like much, but it's all the guts and the software that goes along with it. And then when you start operating commercially, there's some other safety requirements that are inherent to operate commercially. Then you get into another larger multi-copter system, which on it it's hard to see some of the sensors, but this is where you can get into different types of sensors. So you've got cameras on them. LiDAR is coming down in size. You can kind of put LiDAR on a UAV, but it's not quite there yet. Multispectral near-infrared thermal cameras, gas sensors. We're starting to explore it a lot within our company just as another platform to carry a sensor. And that's kind of the thing that you have to keep in mind. The military uses it. It's a drone. It's the exact same thing. It's just larger scale. They put missiles on it. So I was actually at a conference last week in Atlanta, and there was like 350,000 square feet of exhibit space of unmanned aerial vehicles. It's ridiculous the way the technology is progressing. So we're really looking at it as a company as a new data collection tool. So, and that's what we have to realize, that that's all it is. It's another tool that we'll use in different cases. Got to kind of throw the, hopefully reel everyone back a little bit here. There is legislation in Canada to operate a drone. Kind of split into the two sides, being for personal and commercial operations. So, personal side, anybody can go out and buy one. People do stupid things with them, and that's kind of what I need to kind of make everybody aware of, is that there are certain rules that Transport Canada basically has. Is you have to operate safely. So don't fly it over a school, don't fly it over a highway or near a hospital or whatever. Respect privacy. That's one of the big things, especially in the States right now. We're looking into implementing this across with our U.S. offices. Huge privacy issues with drones, which should be no different than just a camera on your phone. It's just the fact is pictures up here or pictures on the ground. So fly in daylight. Those are some of the requirements. Away from airports and away from groups of people, concerts, fireworks, that kind of thing. So just I can't stress this enough. If you fly it, go somewhere away from everything. Because I've crashed mine a number of times, and it does hold up quite well, but they get to a decent size. Like this one's only 3 pounds. I've got one that's about 6 pounds, and it can fly at 100 kilometers an hour. So you have to really be cautious of the systems and technology, what they can do. So for the commercial side, which is how we operate, and anybody that basically would be operating it as part of a company or municipality or whatever, because I know that there's been talk in a lot of municipalities to get them. I think City of St. Albert bought one, and they had an illegal demo to get one, but I'll leave it at that. But there is permitting. Transport Canada basically mandates all airspace. So anything that basically gets above ground, you're now in physical airspace. So you do have to go through a permitting process to be insured, to be able to operate kind of as a commercial entity. So we've gone through this the last 2 years. It's a pain in the neck, but it's part of what you have to do. Operator trainings, we actually have 5 certified pilots on our staff, which are basically like a certified UAV pilot. So we've had to go through a bunch of ground school training to kind of get your certificate to talk to air traffic, that kind of thing. So it's a long ways to go if you operate commercially, but just got to stress that. Again, away from airports, different airspace classes. Urban areas are still kind of frowned upon. You can get permits in urban areas, but they're pretty restrictive. And over roads is also a concern, because they don't want you flying a drone over a road and causing an accident. So just, one thing the FAA kind of has a bunch of paperwork online about know before you fly. So before you go and buy one, for a company personally, just realize what you're up against. Because they're pretty cool toys. Like I love them. My wife doesn't like how much I spend money on them, but that's fine. Okay, this kind of leads us, another type of data capture is photogrammetry. So this is kind of similar to LiDAR with the fact that now you can do everything off of imagery. So basically it's the science of making measurements from photographs. So you might have seen old stereoscopic imagery. You can look at 2 images, and basically by putting them in the right orientation, location, you can actually start measuring, determining terrain. The next advancements in software has been computer vision and I guess GPU, or just computer processing, where it relies on this dense image matching is what it's called. So basically you can take thousands of images from any source, from a camera like this, which is basically just a point-and-shoot camera. You can do ground-based imagery, you can take satellite imagery, you can take other large aircraft, aerial imagery, and it basically uses computer vision to automatically stitch them together, creates ground surfaces, creates terrain, point cloud, all of this data. It's very heavy, but it's all just computer processing time. So advancements in that has been pretty interesting over the last few years. So basically, this is kind of an example up on my neck of the woods. I'm up in the Horse Hill area, so this is an old hull up on our neck of the woods. So I just kind of did a test, and it's only about 5 images I showed here. You basically have to take imagery with photos, and it's got to be enough overlapping imagery, basically to start reconstructing a scene. Basically, fully automated, you can create a 3-dimensional model or point cloud directly from just photography from any camera. So this, again, this works for UAVs, works for ground-based, works for any type of imagery. So you can see the blue locations is basically where it's calculated the image locations. You don't even need to know where the pictures were taken. The software is actually intelligent enough to work backwards and based on computer vision be able to stitch everything together to create a 3D object. You can take that and turn it into like a mesh. You can texture it. We can fill holes, clean it up, all that kind of thing. So this type of technology has been huge in just visualization aspects. In video game industry, you do tons of photogrammetry. To the fact you can use very simple cameras and not very expensive software, just takes a long time to process to create some pretty realistic scenes. Kind of get into the accuracy of it. This is zoomed into one of the corners, and it's very similar to accuracy what you can get from, like, say, a terrestrial laser scan. It is subject to a number of things. That contrast in imagery is necessary. For flying a drone over something that's all white, or taking pictures of something that's all white or mirrored, it has a real struggle trying to reconstruct anything because everything looks similar, or it's not reflective, or just not a lot of contrast. So similarly, from an aerial platforms, this is all actually imagery captured from our drone. So this is a project we did up in Strathcona County, where basically you just fly the area, program a mission area on like a Google interface. You shake it 3 times, hand launch it. It flies itself. Yeah, it seems a little hokey, but that's exactly what it does. And basically, in the end, you get a 3-dimensional point cloud of all data constructed from a 16-megapixel camera. So this is where you can put it on any type of system, fly an area, capture data. The downside is, compared to, say, LiDAR, is around trees, you see there's like gaps basically under vegetation, because it is entirely based on line of sight of what you can see. So just one of the limitations of it, but pretty cool for being able to get it up in the air and take about 300 images of a site, and you can actually get a bunch of data out of it. So this, again, this will work for any imagery. We've done a lot of reconstruction with satellite historical imagery. You can actually take any image sources into this program. It'll match everything together, stitch them, create one seamless point cloud data set in the end. So very, very advanced software. Again, you can turn it into a ground surface, and then you can actually even get an orthophoto in the end. So it stitches everything together to get a correct photo in the end. So this is very accurate, and this is really what our bread and butter is with these things, is we're using them for more terrain mapping, topography, that kind of thing. So.